You know how we all use the words speed and velocity like they're the exact same thing? Well, what if I told you they mean two completely different things in physics? By the end of this, you'll not only get the difference, but you'll see why it's a distinction that really matters for everything from just driving your car to launching a rocket into space.
All right, let's kick things off with a little puzzle. Imagine two cars, both cruising along at a steady 40 kilometers per hour. So, are they moving in the same way? Your first instinct might be to say, yeah, of course. But the real answer is a little more interesting, and it's the perfect way to dive into our topic today. So, to crack this puzzle, we've got to start with the part we all think we know. Let's break down what we're actually talking about when we say how fast something is going. When we talk about speed, it's really simple. We're talking about one thing, how fast something is moving. That's it. It's the number you see on your speedometer. It's how quickly a runner finishes a race. It's just the pure rate you're covering ground. Okay, this brings us to a key concept in physics, the idea of a scalar quantity. Now that sounds technical, I know, but all it means is it's a value that's just a single number, a magnitude. Speed is the perfect example. It tells you the how much, 40, 60, 100 kilometers per hour, but it gives you absolutely zero information about the which way.
And calculating speed? It's as easy as it gets. As you can see here, you just take the distance something traveled, divided by the time it took to go that far, and boom, you've got your speed. So in this example, 20 meters in 10 seconds gives us a speed of 2 meters per second. Super simple.
Okay, so we have a pretty good handle on speed. But let's circle back to our two cars. Does knowing their speeds solve our puzzle? Not quite. There's another piece to this whole thing, and honestly, it's the one that changes everything. And this is where it all starts to click. Think about it. One of those cars could be heading north and the other could be going south. They have the exact same speed, but are they moving in the same way? No way. The missing ingredient we've been searching for is direction.
And this brings us to the other hero of our story, velocity. Velocity is basically speed with an upgrade. It takes the how fast from speed and adds the all-important which way. It's speed, but with a specific direction attached.
Let's look at this another way. If you just say an object is moving at 60 kilometers per hour, you're only giving it speed. It's just a number, a scalar. But the moment you add a direction, north, down, 30 degrees east, you are no longer talking about speed. Bam! Now you're talking about velocity. It's a subtle change in language, but it's a powerful difference in meaning. And that's what makes velocity a vector quantity. Unlike a scalar, which is just a number, a vector always has two parts, a magnitude, that's the speed part, and a direction. You need both to describe velocity. And if you change either one of them, you've changed the entire velocity. All right, now that we've met both of our contestants, let's put them side by side to make the differences crystal clear. It is time for the official showdown, speed versus velocity. Here's the breakdown in a nutshell. Does it include direction? For speed, that's a hard no. For velocity, that's a definite yes. What kind of quantity is it? Speed is a scalar. Velocity is a vector. This simple table really captures the one fundamental difference between the two. So, let's go all the way back to our initial puzzle. Two cars, both going 40 kilometers per hour. Are they moving the same way? And now we know the answer is a big fat no, unless they happen to be traveling in the exact same direction. They can share a speed, but they only share a velocity if their direction is also identical. So you might be thinking, okay, that's a cool little physics tidbit, but does it actually matter in the real world? And the answer is a huge yes. This distinction is absolutely critical in fields like aviation, weather forecasting, and even sending probes to other planets. Let's dig into why direction is everything. To really drive this home, let's chew on another little puzzle. Is it possible for an object to have a totally constant speed, but a constantly changing velocity? Take a second and think about that one. It sounds like a trick question, doesn't it? But the answer is absolutely yes. And the perfect example to picture is a car driving in a perfect circle, like on a racetrack or a big roundabout. Let's break this down. The car's speedometer could be glued at a steady 30 kilometers per hour, so its speed is constant. But to stay in that circle, the car has to be constantly turning, right? Its direction is changing every single moment. And, as we just learned, if the direction changes, the velocity changes. So there you have it. Constant speed, but constantly changing velocity. This is a fundamental concept that explains everything from a satellite orbiting the Earth to the feeling you get on a roller coaster loop. So, we'll leave you with this final thought.
Your car has a speedometer, which tells you your speed. But to know your velocity, you actually need another common instrument. Any guesses what it is? It's your compass, or these days more likely your GPS. Because to truly understand motion, it's not enough to know how fast you're going. You also have to know which way you're headed.